I'll be going over the umpire process for a number of times. Binary string is prefix aligned. So for understand, so let's see. So we're given a flips list of integers. Given flips list of integers. So we're given a one index integer array flips, where flips I indicates that the bit at index I will be flipped in the ith step. So we were given the light bulb problem, or in this case, we're thinking of it in binary. So if we have a list of zeros, then at that index, so these are the indexes where the zeros will be flipped, or where the light bulbs will be turned on. So flips are a list of integers where the light bulbs will be turned on, or zeros are flipped to 1, depending on how we want to think about it. And that's our input. And then for our output, we want to return the number of times the binary string is prefix aligned during the flipping process. A binary string is prefix aligned if after the ith step, all the bits in the inclusive range 1 to I are 1s, and all the other bits are 0s. So we want to return the number of times bits in the range are prefix aligned, or if we're thinking about it in terms of light bulbs, when all the light bulbs are blue. So for an example, if we're given so if our input well, that's what I hit previously, but I'm just gonna hide that. But for input is 3, 2, 4, 1, 5. Then our output should be 2, because right, so we're given 3, so like it says here that 0, 0, 1, that 1 at the third, let's see, think of it as like the third step. Yeah, I mean, so this would actually be 0, 1, 2, right? But we're thinking in terms of length, it'd be a 1, 2, 3. So we'll just say like the third index. So that's gonna be a 1, or the light bulb will turn on at 1 at the third index, and then 2 will turn on, and then 4 will turn on right here, and then 1 will turn on. So from then we'll have like a row of 1s, where each one in the previous, it's either a 1 or the light is turned on. So we didn't have that before then. And then right here, so depending on like what our max rightmost number is, so in this case like 1 is our rightmost flip number, and it's still 0, so we didn't have it. This one, the third 1, is the rightmost index, and then we still didn't have it. And then this one becomes 4, still didn't have it. And finally, when we have the 1 flipped, we finally get it with having everything previously 1, where all the lights turn on, and then it goes to 5 right, and then they're all turned on. So that's why we get 2. And then for given 4, 1, 2, 3, then our output should be 1, because right, so we have 4, that's our rightmost, right? So we have 4 turns on, everything's still 0, and then we have 1, and then 4 is still our rightmost, and then we still have 2 zeros here, so it doesn't work. Then 2 is turned on or it's flipped, so 1 1 0 1. And then finally with 3, they're all turned on before 4. So we just get one moment where the string is prefix aligned, or all the lights are maybe blue or all turned on before the rightmost index. Okay, so next we have matching. I don't know if I've seen this problem before, but I've definitely dealt with like strings and lists. I definitely use like flipping numbers before, flipping numbers. And then, you know, this is going to use loops. But yeah, I don't know if I've seen this problem before, maybe something similar, but I was thinking like at first I'd be using a on list, so maybe like checking if numbers are in a list, you know, something like that, counters, but I was able to find a simpler solution. So for the plan, so I would just create right and prefix aligned variables, and then we want to iterate over flips, and then we whoops, I should say flips. Then we want to find the maximum flipped number, or like we say like number index, right? In flips, we want to find the one that's most to the right that's turned on. Then we just want to check if our max is greater than I plus 1. If it is, that should mean that all the numbers before it are flipped, or all the light bulbs are turned on. So we'll just, if it is, increase prefix aligned by 1. Okay, so, okay, let's see. So for implement, so right, we'll have a right variable equaling 0, finding our rightmost flip number or light bulb, and then we'll have our prefix aligned, so we're trying to find the number of times the list or string is prefix aligned, so we'll have that equals 0. Then we want to iterate over flips, so for I in range len flips, so we're iterating over flips, and then we have right equals, so we're trying to find the maximum between right and the element at our index, to see like which number will be turned on in our like binary list. So then we check if right is equal to I plus 1. If it is, we just want to increase prefix aligned the number of times the list or string is prefix aligned by 1, because if our max is greater than our index by 1, then it should mean all the numbers before it have been flipped, or all the light bulbs have been turned on. And then we just want to return prefix aligned, the number of times our string or list has been prefix aligned. So I'll run it and submit. And then yeah, we'll get it. And in terms of evaluate, it should be O of n with space of O of 1. Okay, I think it's my solution for number of times binary string is prefix aligned.